I'm Ramsey. This is Tims. So, first, how many people have seen the Strange Loop talk? A couple of people? Okay. I just want to drag people through something we've already heard. So, Tims and I spent the last couple of months building this thing that we call Arcadia. And it's an integration of Clojure, which everyone here knows, into Unity, which some of you here know. Unity is a video game engine that I've been using for the past 5 years to develop games, which is what I do for a living. It's the industry standard. It's an industry standard tool to build games. It exports to, this is my favorite screen from Unity. If you guys can see that, PC, Mac, Linux, iOS, Android, Xbox, PlayStation, and Wii, and like basically everything you could ever want, a video game to run on. This will export to it. It's free to use. It's built on Mono, architected very, very well, and their goal is to democratize game development. So it's really meant to be easy to pick up, and it is. But you get a really powerful sort of graphics system with it. So what we did is we built on the work that David Miller has done to port Clojure to the CLR, the Microsoft Common Language Runtime, and we basically forked and hacked the compiler and got it to run inside of Unity. So what we're going to show tonight is not, some kind of network interop thing. This is like code actually running inside of the Unity editor. And when you export your games or your apps, it's Clojure running inside the exported apps. This is the first talk that we've given on this, that we're going to do no slides. We're just going to dive right into live coding. So if the building collapses or like terrible things happen, it's blame our buggy compiler. Keep that in mind. So we're gonna build it. I'm gonna build a game. I'm gonna build Flappy Bird for you guys. That's the plan. And if that doesn't work, I've already built Flappy Bird. So there are like little files here that I can follow. But in doing that, I'm gonna try and give you guys a sort of overview of Unity, why Unity is interesting and exciting, and how Clojure and Arcadia sort of integrates with that whole system. If anybody has any questions at any point, sorry behind me with that. If anybody has any questions at any point, please don't hesitate to jump out and ask. So this is Unity. You have a couple of things going on. You have a thing called, this is your scene view, where you could sort of set up your level or your game. I can select an object here. You have your inspector that gives you information on any currently selected object. You have your hierarchy, which is basically a list of all the objects that are currently in your game. Project, this is a list of all the files that are going into your project. And the very important console, which I spend a lot of time looking at. So Unity is an exciting target for Clojure because in addition to being a very powerful graphics system, it's built on what's called the entity component system model, which is a fairly standard design pattern in the video games industry. So the professional video games industry is largely still based on C++. But they've more or less abandoned traditional inheritance in most cases, so you don't really build deeply nested class trees. What you end up doing is you write classes in a very shallow inheritance tree that are called components, and those components implement the behavior of your game. And then you attach those components to objects. So in this kind of system, the way that Unity works, there's no special camera object in the engine. There's a game object, which is generic, with a camera component attached to it. This allows you to like mix and match functionality and behavior in a way that for a video game is very, very important, to be able to like remix things. So you get that with Unity, and Unity makes an effort to make all of its components serializable. So they have a data only on disk representation, which makes it play very, very nicely with Clojure's persistent data structures, which Tims is going to show you guys in a bit. So this is the scene view. I can create, get a cube. There's a cube. I love the cube. It's 3D, right? But you can switch into 2D mode, which is just ignores one of the axes more or less. And you see when I select the cube, I can see all the information on the cube. So to start building our world, well, here's play Flappy Bird. So Flappy Bird is a game that is interesting for historical and political reasons, but also the mechanic is very, very simple. You're a bird that's flapping through a series of pipes of varying heights, and if you hit a pipe, you lose. That's the entire game. So the first thing we want to do, I took the liberty of grabbing a sprite sheet for Flappy Bird. You all see that? So all the art. So in 2D games, you'll very typically pack all of your art into a single image. And Unity is very, very good with that. Just to show off one of Unity's features, you're able to sort of automatically split up all the assets into separate little sub-sprites. So we're going to be using these guys for the pipes and this little animation for the bird. So I've already split those up. And I'm going to create an empty game object. I'm going to position it at 0, 0. Can you guys at all read what's going on in this column?
No.
I'll try and read out the values. We don't have any zooming, unfortunately. So I just created an empty game object and positioned it at the origin. I'm going to add a component. So this is the bread and butter of what you do in Unity, which is create objects and attach components to them. In this case, I'm going to attach a sprite renderer because I want to draw art. I want to draw 2D art. And I'm going to choose this background. There you go, little background. So put that here. And I'm going to go back to my camera. Just zoom in a little bit. And set the background color to white. And you're not really supposed to stretch out sprites, but that's fine. There we go. So there's our background. So another thing that makes Unity an exciting target is that as opposed to talking directly to OpenGL, which is perfectly fine, there's nothing wrong with that, but Unity is exciting because you have this entire authoring tool, right? So I'm going to be doing a lot of stuff in the REPL and a lot of stuff in Clojure, but there's some stuff that you just want to be able to rough in, right? And Unity gives you that because you have this entire editor. So this is my background, and that can just stay put. I'm gonna rename the object to BG. That's my background. So now, first thing I want to try and do is create the pipes. So in Flappy Bird, you have this sort of infinite barrage of pipes that are coming at you, and you have to like fly around them. So to do that, I'm going to create another empty game object. I'm going to add a component. It's also going to be a sprite renderer. But this time, I'm going to choose this upright pipe. And it's not showing because of the Z order. There's a sprite. There's a little pipe. So you can see that the scene view on top is where you can sort of lay things out. And the game view in the bottom is what the final product will be. This is the sort of perspective of the camera that's in the world. The camera, which of course can also itself be moved. Again, everything's fully 3D, even when you're making a 2D game, which is nice to be able to get like an exploded view of what it is that you're doing.
Do you have to set like the default like window size to like phone? Is it like at a phone setting right now, or is it?
Oh, it's at free aspect right now.
Okay.
You can set it to yeah, you can feed it specific resolutions and set that up. Unity tries really hard to not have specific pixel dimensions set. Their goal is to be as cross-platform as possible, but yeah, you can kind of force it to be a particular resolution. That's also important for installations where the projector can be a fixed resolution, so there are ways to do that. But right now, it's whatever the size of the window is. So it'll grow and shrink, so that'll break it. But yeah, you can set that. So here's our pipe. So what we want to do is make the pipe move, right? And in order to implement behavior, you write a component. Normally, you write this in C# or Unity's implementation of, they call it JavaScript, which is a complete misnomer. A lot of people ask us why we didn't just compile ClojureScript to Unity's JavaScript, and that's Unity's JavaScript is a very thin, poorly engineered shim on top of Vue, which is itself a very thin, I'm not gonna do it. But it's, yeah, nobody really knows why they did that. But it's not, Unity's JavaScript is not real JavaScript. So we compile directly to CMR bytecode and just don't deal with any of that noise. So to add a component, we need to write one first. And we don't have Our add component menu item is a little bit buggy. Normally, you just go to Arcadia, new component. You can't really read that text, but that's what that menu item is. So I'm just going to do it from the terminal for that. This is trusted terminal. Oops. So I just created a folder on the class path called Flappy. And I'm going to make a pipe.clj. So this is my pipe.clj. So Flappy pipe. This is what you would expect. So we have a couple of nice things to use. So Arcadia core has a lot of the core interop and component functionality. Always included. We always use it because it's sort of understood that you're working in this environment. These are the basic things that you need. Let me save that. Give it a second. And our compiler, see the beach ball. So part of what Arcadia does is it's able to pick up CLJ files, compile them correctly, put them in the right folder, make sure that Unity can see them. So you'll see that if I go click on this pipe and say add component, oh, I haven't created a component yet, but we'll be able to. So I can show you guys from the REPL. So the REPL, this is our REPL into Unity that is working. I can. I'm using Sublime Text. Forgive me for that, but it's one of my few vices. So now I'm in the Flappy Pipe namespace, and we've used Arcadia Core, so I can show you some of the stuff in Arcadia Core. You can query the scene graph for objects with a particular name. Or not. Maybe that doesn't go through. Oh, everything's breaking, as it often does. So this is the building collapsing.
You didn't close the code on your requirement.
No, this is a use. This should just do it. That's
Is it object named rather than object name?
yes. So the thing about function names is all the letters have to be there. Sorry about that. It's a quirk of Unity, if you will. So object named will do a name lookup into the scene and pick up whatever object you need. This is a great way to be able to query and reach in. And what comes out is a Unity, like an actual game object. So this is the reference to C# type that you can do all kinds of stuff too. So you could ask, what is its transform? We have reflection warnings turned on because we were optimizing, but you could ignore them for the REPL stuff. So again, in Unity, everything is a game object, and a game object is an empty just container of components. So to do anything useful, you have to talk to a component. So here I'm requesting or querying the transform component of the camera object. So transform is what encodes position, rotation, and scale in Unity. So if I continue with this form, transform position, I get its position. It's at 0, 0, minus 10, and z minus 10. So I'm new to Clojure, and I've been doing C# and dirtier languages for a very long time. And that syntax to me is so beautiful and so exciting. You just shoot right in, and this is an interop form, right? Like this isn't even cool stuff. So I just love just being able to do that. It's very, very, very elegant. Other ways that like I said, the editor is great and the REPL is great, and they play very, very nicely together. So if you import selection, So that'll return whatever object you selected with the mouse. So you can very easily like select something with the mouse and then apply REPL logic to it and then move back and forth. If you select a bunch of things, you get a sequence of all the objects.
Is this read-only, or can you manipulate these objects?
Yeah, you can manipulate them. You can do seq over them. Do whatever you want. Well, let me create something that. So if you have like some stuff that you just want to play with. So I'm just going to select these guys. You could do see objects, selection objects, and you can add components. What do I want to add these guys? Rigid body 2D, is that how you spell it? Yes, it is. So you come back, and all of a sudden they all have rigid body 2D. So rigid body 2D is the Unity component that gives an object mass in the physics engine, right? Yeah, so they're totally open to manipulation. It's not read-only. For better or for worse, sort of the tension between Unity really wanting to do in-place mutation and Clojure really wanting to do Clojure is just an interesting tension that we've been balancing. And then I can, if I don't want these anymore, so it'll go away. So to make the pipe move, you have to create a component. That's the only way you interact. That's your sort of interface to the Unity system when you're building a game. So to create the pipe component, moving pipe. So def component is an Arcadia, a thing that's particular to Arcadia. This is part of where we had to hack the compiler to make it work with Unity. So Unity components have to inherit from mono behavior, which is that's the Unity component type. And so they need a particular superclass, and it has to emit a named type. So these two things, there's no Clojure construct that did both of these things. So we ended up sort of writing our own special form, which it does exactly that. It emits a name type of a particular superclass. But other than that, it basically behaves like def type. It's designed to. So I can give it the parameters or its fields. So it's going to move at a particular speed. And then you have to implement one of Unity's messages. And I say that with gigantic air quotes because that word is meaningless. It has no formal meaning. It's just the Unity has a list. Unity has a list that they call messages. Oh, let me see CSS breaks. Y'all kind of read that?
Yeah.
Awake, late update. So these are functions, these are methods that if you implement them on your component, Unity will find them and call them at the appropriate time. So on collision enter, if your component is attached to an object that has a collider to give it shape and a rigid body to give it mass, and it bumps into something, the on collision enter method will be called. So these are your hooks into Unity's event system. Of course, it's C# object oriented, so you expect it to create a subclass and implement these methods. And def component mirrors that in a def typey kind of way. So the most important ones are update, this gets called once a frame, and start, this gets called at the beginning. These are the ones you end up writing sort of most of the time. So to update, the way you make a pipe move is, you would not type it directly. So update this. Our def component will automatically insert a protocol that you would normally write. It just gets kind of obnoxious to have to write a separate protocol for every single one of Unity's 40 messages, so we just do that for you. Again, def component is intended to be entirely just an interop form. You sort of do it and get away from it as quickly as possible. So update, we say this. So this refers to the component. So this transform will get you access to the transform that, so you can have components talking to other components. So you'll get the transform that is attached to the current object. Translate. Then you feed it how much you want to move in x, y, and z. So in x, we want to move by whatever our speed is. Speed. And then y is 0 and z is 0. We save that. And we jump back in. Compiles the component. And now I can say add component, moving pipe. And you can't see it, but there's a little speed thing that shows up in the inspector. And even Unity gives it a little icon in the corner, which I think is hilarious. Like components get their own icons. If it's C#, it's a little C# icon. But in this case, it's just a little Unity file icon because it has no idea what it is, but it's consuming it anyway. So we've said sometimes that Arcadia works better than it should, and this kind of complete seamless integration into the actual visual GUI, it was like more than we were expecting Unity to be capable of.
Did it need the type annotation there?
If you didn't have the type annotation for float,
Yeah.
you don't need it. It'll emit a field of type object, which means that Unity's, so Unity's default inspector won't render a thing of type object. So I know it's really small for you guys, but it just
I
disappears.
can see what it's called.
Yeah. So that's not a huge deal. You can write custom inspectors in Unity. It's just nice that the default one will work with type annotations and stuff.
That translate, that's a Unity script method, should be again?
Yeah.
Okay, so the def function is basically just taking anything that's named like one of the Unity script methods and then calling,
Yes.
calling it from it.
Yep. There we go. So if we jump back in here and we run it, we'll see nothing. The speed is 0. But if we set speed to 1, she's off. Set to -1, it comes back. Video games. So what the normal workflow is you would sort of tweak your component and then go back into Unity. Unity does have a code loading solution for C#. It'll like compile and swap in your components on the fly. But we have a REPL, so there's like no need to worry with that. And a workflow that we've settled in is, especially for REPL stuff, is to just forward declare a function because the component has to recompile if you're going to update its contents. You can't really update it from the REPL because it really has to hit Unity's compiler pipeline. But when doing it from, if it's just sort of calling out to a Clojure var, then you could redefine that from the REPL a lot. Joseph Parker, who's here, someone around you, yes, is one of the very early adopters of Arcadia, sort of really made this pattern kind of a thing that we can't stop using. So kudos to him. Okay, this. And I can paste that right back in, and this will work in a way that allows me to. Here.
You don't need to pass speed.
Oh. Yeah. There we go. Yeah. So this is a type moving pipe, and it'll be able to pick it up. Cool. So that compiled, and now run it. And so it's still 0, so I'm just going to make speed 0.1, and that moves. So I'm going to leave it running, and I'm going to do some stuff from the REPL. So I'm in the Flappy Pipe namespace. So one of the interesting things about REPL-driven development of a video game is I ran into this while building the demo for Code Mesh, which is we built a game with a bunch of like cats wandering on a platform and then falling off the platform. I would write some code and turn around and all my cats had fallen off the platform, and I couldn't really I had this code but all my cats were gone. So in this case, the pipe is gone, and if I tweak this code, I won't see it. One of the things that I've started to do is, and this is the kind of stuff that may be folded into core eventually. I just create just a reset world function. So import the application namespace. Say application, load level, application, loaded level. So this is a Unity trick. So you basically load a level, you load the current level, which flushes the state and returns it to what it was when it started. So if I eval that, oh, right. So I re-eval the NS form, so now I should be able to see reset world. And then reset world brings our pipe back. This is a nice trick to if your world sort of runs too much and while you're making changes, you can bring it all back. So the one thing, and it reset the speed to 0 as well. So this guy's called, So the pipe is still called game object. I just never changed it. So I'm just going to update this name. So now it's called pipe. And now I can set its speed back to something reasonable. If I set object name pipe. Get component. So these are interrupt forms, and it's all visible to C#. So it goes into the Flappy pipe namespace. So we get the component, and we set the speed to be 1. It doesn't like it. Oh, God, yeah. So Unity, right. So it's a double float issue. This might actually work. There we go. So yeah, so Unity, and the reason I wrote float instead of double up here is the habit that you get into Unity. Unity wants everything to be floats. Clojure wants everything to be doubles. This is just a thing that can get a little annoying. So now we have reset world and give it speed. Oh, right. So resetting the world changed its name too. So let's leave it at that. So now we can reset the world and assign it a speed. So the problem with the current implementation of speed is that it's too fast. Even a speed of 1 is too fast. So you can reduce the number to make it slower. But the correct thing to do in game development is you actually want to multiply the speed by what's called delta time. So that's the number of seconds since the last frame, which is usually a very, very small number. And that gives you a smooth, time-based. So now you're not moving 1 unit per frame, you're actually moving 1 unit per second. So if I re-eval this update, and I give it speed, now it's moving at 1 frame per second, right? A -1, and now it should be moving backwards. There we go. So there's a pipe. And then you would go on, right? You would say, okay, well, if the pipe goes too far, so let's see, how far is too far? Because we want to set it back to the beginning. So when it reaches about -1, let's just say that for now. When it reaches -1, you want to reset it. Like you basically want the pipe to move off screen and then come back at the other side of the screen. That's how you create an infinite series of pipes. So if less than transform this transform position x -1 set this transform position x to 2. Go. Why would you go? Hey. Hey guys. Okay. Yeah, it should be. Make sure that it's actually calling it. Debug. New code. What are the challenges? Oh, yeah, it's calling new code. So you can't really see it, but in the console, it's just printing out new code all the time. So yeah, so that's one of the challenges of like building this. This is still very, very alpha. You sort of don't know if the framework is breaking or if you're breaking. But in this case, it is actually picking up the code change. So if the position...
Are you sure you want a less than?
It's moving to the left. So it, I imagine, so it moved to here. This is where,
Oh yeah.
right?
It should be less than.
It's minus, this is -1. So if the position is less than 1, that shouldn't make a difference. But set the position to be like that. Well, let's try this. Log. And so now it's printing out the value. It's -14. So now let's actually print out. I mean, do you think that you're less than -1? So I'm getting a bunch of trues. So this is definitely true. So this branch must be evaluating. Oh.
Does it just get updated again with the speed, which is still times the time, back to where it was?
How are we? So we're doing a translate, which is relative. Like it just moves it to the left a little bit. So that should be okay. I think the problem is that I'm trying to set an individual component, and Unity generally doesn't like that. So let's try and set the whole position to just a new vector. So vector 3 is how Unity encodes position. Let's just use vector 3, 0 for now.
So delta time is still from the beginning of the time?
Delta time is the number of seconds since the last frame. So it's like 0.0001. And that's what, so you multiply 1 by delta time, and you're now moving per second and not per frame, like 1 unit per second, not 1 unit per frame. So let's try this. Actually, I think that was it. So now we know what vector 3 is, and we come back and we re-eval that. Oh, there we go. There we go. So the problem was, and this is just the way Unity is built. It generally doesn't like you to update individual components of position, which is a thing that I obviously tend to forget. They want you to reassign the whole position in one go, because positions are value types and they have certain semantics. But the important thing for this talk is that was entirely debugged, right, and reasoned about live and interactively. Whereas in C# or any other comparable environment, I'd be like patching and recompiling, patching and recompiling, patching and recompiling. And for a bug that's not as trivial as this, that stops being fun very, very, very fast. So we want to put this at 2, and then 0, 0. And now we have something that's a little bit better. Maybe 2 is too much. Maybe 1. What does that look like? There we go. Is it? Yeah, that's good. So now we have like a little pipe, and the 0 is a little high, so let's do that 1. No. wrong direction. There you go. Now you have a pipe. You have an infinite sort of scroll of pipes. And then the next thing I would do is I would save this, come back into Unity. Now that I've done my live REPL stuff and I have a component that I'm happy with, I can do the Unity thing of, so I could do this in the REPL as well, but I'm going to do it from the inspector just to show that part of the experience. Oh, right. Comment that stuff out. Boom. And so now I have this pipe. It's doing what I want, and I can duplicate it, and I can put this guy at like a different height, duplicate it, this guy at a different height, and that. I think the Y's are probably going to get reset according to this logic. Oh, and they all have speed of 0. So give them all a speed of 1. Let's see what that looks like. -1. I don't actually know geometry. I just sort of like multiply things by -1 until it looks okay.
It's so endearing watching.
Oh, so now the Y's are being reset. Right. So let's actually fix that here. So it's being reset because we're always setting the Y to be -1. What we actually want to do is we want to set the Y to be this transform position Y. So we don't ever want to change the height. Let's say, I mean, you can randomize it here. You can do whatever you want. But let's go back to the namespace and reevaluate that. So now I can, nope. 1.2, there we go. So that guy stays low. And this guy, let's make it a little higher, so 0.9. Oh, so now you're all the way over there. 0, yeah. And boom.
Maybe it can't be wider than 1.
Which the
Like all the pipes that can't be wider than 1.
the X values or
Yeah.
they
Like.
yeah. Because it's being reset between 1 and -1. So I just paused the game because I wanted to like sort these things out a little bit. So that's 0, put you at 1, put you at 2, and I just want to sort of tweak the heights. Let's put that guy there. That might be a little too high. Let's put it lower. So now we have a couple of heights. What does that look like? Oh, then there's still.
Yeah, you maybe want them all within one screen width.
Oh yeah, that's what it is. So they're just jumping away right away.
Yeah, just jumping onto each other.
Cool. So that's 0.6. Yeah, just rough it like that. Yeah, there. And let's pause it one more time. And so I duplicated all of them, and now we rotate it. Run that. Nope. We do not run that. Because they were rotated, the direction vectors are all different. Okay. So I do make games for a living, I swear to God. This is just what the process is like. And then you, let's just say, okay, why not? So you and you are at minus 0.6. And then you and you are at 0.1. And then you and you are, you are at 0.6. Okay. Oh. Now if you just look in the screen at the bottom, which is what your users will see, this starts to look like the terrain of Flappy Bird. And if we wanted to get cute, which is the whole point of games, we multiply the original, or we add to the original position a random number, so let's say a random number between 0.1, make sure I have the right namespace, and yep, there you go. So now the pipes are all at random heights. And you have this very simple, like little terrain going. How are we doing on time?
8.
8? Do you want to show your stuff off?
Sure. I mean, is it going to take a while to get a bird in there?
Well, I mean, I can use the old bird component.
Okay.
Yeah. So this. So now, oops. So yeah, I had the pipe where the pipes are the more sort of intricate. And this is what the bird looks like. It's a sort of daunting 9 lines of code. Basically, in Flappy Bird, the bird is always just hopping upwards. So we say if any key is pressed, then we get access to the rigid body, and we just add force to it. And force is a parameter that you can set externally. So to create the bird, again, as with everything, I create an empty game object. I attach the bird component, and I'm going to give it upward force of positive 1 in y and 0 in x, so we just go straight up. To make it look like a bird, I'm going to add a sprite renderer. Flappy Bird. And then to make him flap, because we do not cut corners, we add an animator. And this is an animation that I set up beforehand. So, oh, and he needs a rigid body because he's physics. So, rigid body. I'm going to lower gravity. So gravity is normally at 1. I'm going to set it to 0.2, just to slow things down a little bit. And if we run,
Man.
come on, guys. Come on, hey.
So if you hold down the key, he takes off?
Yeah, every time I tap, it gives him a little bit of force upwards.
What if you hold down the key?
Yep, false. I believe in you. And then to round it off, to make him actually collide, I would give him a circle collider. So colliders are what give things shape in the physics engine. I don't know if you can see the light green outline of the bird. That's what sort of determines how he will collide with other objects. And then I will give the pipes, which I'm going to delete. Should be minus 1, right? So I'm going to give the pipes box colliders. So he's shaped like a circle, and the pipes are shaped like boxes. And yeah, and that should be it. And then we could sort of set up our level. Live game. So that was a nervous tick, Command S. And when we duplicate these guys here, and rotate them. So the reason the pipes were popping in and out of existence is when you change things while the game is playing, Unity doesn't retain it. Which is by design. It allows you to change things without sort of permanently breaking your game. So then I think these guys need to go in the opposite direction now. So this should be 1. I'll probably fuck that up. Let's go. Oh, it actually works. Come back, come back. Oh, now he's all the way up there. So if he hits, you see that the pipe's actually going backwards. So this is where, if you wanted to make it so that the game ended when that happened, you'd use on trigger or on collision enter, and you would just delete the bird, destroy the bird. But for now, you just have this little sort of impossible struggle against those oncoming pipes. Okay, you could like rest on them. No. And that's Flappy Bird in Arcadia. Do we have time to show off a little more magic, or how are we?
Maybe I could just show you guys like 10 minutes of something from a slightly different perspective.
Yeah.
So Ramsey and I are working together. Ramsey knows Unity better than I do. I know Clojure a bit better than Ramsey does. We've been doing both of these respective things for like about 5 years each. And
You know a lot better than I do.
so I'd like to show, so this is a very stateful, interop heavy kind of approach to the Unity scene graph. And I'm going to quickly, again, and everything doesn't explode due to caveats to live coding, show you guys another approach to this stuff that you might want to try out. So first we're going to try and get into the thing. Oh, that worked. Wow, okay. Astonished. So, not because the infrastructure here is bad, but because my computer is bad. Okay. My instinct as a Clojure developer is to get as far away from anything that's stateful and mutating and difficult to reason about for as long as I can. Now that's difficult to take as an absolute in a games context because the performance considerations in games are completely uncompromising. And if it's like 1.5 times slower, you're dead. You have to do this at 60 frames a second. You have to run a three-dimensional physics simulation, sometimes over like tens of thousands of objects, each one calculating collisions and so on, and it's a mess. For like the lowest level stuff, you just can't afford to be purely functional until maybe some future games engine could do this, but Unity can. Which isn't surprising. It's very demanding. However, there's usually some sort of higher level abstractions or like part of game design in general that you can rely on. So we have a experimental, like everything else, namespace called Hydrate, which converts between Clojure persistent maps and Unity components. This is under the conceit that the Unity scene graph can more or less be represented as associative data structures, sort of a database of associative data structures. It's more or less flat. Sometimes it's nested. Most of the time it's flat. So I'm going to start by showing you a bit of the just my workflow for setting up some stuff. This is a scene I was using to play with Quaternions and figure out how they worked in Unity. Oh, another thing that's worth mentioning for those of you more used to the JVM, which I assume is most of you, the CLR has a very interesting feature called value types, meaning that you can extend the range of primitive-ish types. Vector3 in Unity is a value type. It's not a reference type. It's immutable. All of and there's I think 281 value types just in Unity. You can extend these. You can define your own, and that's great. It means that it makes our work as Clojure programmers much easier. We don't have to worry about mutating things in the leaves of all these components. So
yeah, it's important to mention that the functions that Unity provides to manipulate Vector3's Quaternions for rotations and matrices all will run in non-main threads, which is not usual for Unity. So you can do like linear algebra in separate threads, and then fold it back into the main thread, which we're very excited about.
Which brings up another thing, which is that mutating the scene graph all runs in the main thread in Unity, which is nice in a way because it means that we have we don't have to think about concurrency too much there, and it's bad because we don't have to think about concurrency too much there. But yeah, for all the like spatial computations you can do in another thread or an agent or whatever you want. You do have access to other threads at this point. It's just not when you're changing the scene graph correctly. Here I have a disk in the world, and here's a form that I defined for it. Def SCN has a little garbage like fake corny garbage collecting thing. I can show you that macro right now. So what this does is if there's a, it defines a var. If the var is already in the scene and attached to a game object, then it destroys that thing and then repopulates it, reinstantiates it with the, whatever it is you want. This means that from the REPL, I can go to, let's see, I can change this somehow. I can move this over here, and then.
Can everybody see the code?
Yes, is this big enough? Not that, but this. Is this big enough, or should I make it a little bit bigger?
Bigger would be good.
A little bigger? Okay. All right. You amazed by my ability to make text bigger anyway.
It's another feature of Arcadia.
So, and then if you reevaluate that form, it just puts it back where it was before. Okay, so I was trying to figure out how Quaternions work and how to pivot objects. I'm going to show you a form here. So first of all, I started out with a little asymmetrical pointer thing made out of Unity primitives. And you'll see that to create this, I fed in a Clojure map with a certain nested structure that's I'd have to explain with more time than we probably have right now. The point is I'm just manipulating functional data structures to get this pointer in the first place. And then I call hydrate on it. As soon as hydrate hits it, it does as, and it's doing this as fast as I know how to make it right now. It's walking that that data structure and constructing a fresh Unity object on the basis of it. Each of the keys there, well, most of the keys there correspond to Unity components underneath the top level game object. So the transform is the transform object. Under transform, you have local scale, which is the canonical representation of where that object is now. And we have the game object. Okay, so now we have pointer trans. I'm not very good at names. Let's see. So this is it takes the existing thing in the scene. You'll notice that I didn't actually define the map I'm using to construct the pointer anywhere on the top level. I don't need to because it's already in the scene graph. So I go here to dehydrate, which is the inverse, hopefully, of hydrate. It hopes to be idempotent with hydrate, so you can just populate something into the scene graph and then dehydrate it. And after you do that twice, you wind up where you started. So ideally, okay, so I use that to grab whatever definition of that happened to be. Then I have some other functions defined. There's spec pos plus spec scale times. These are just little conveniences I wrote to reach into Clojure spec and multiply or add the vector trees I find out there. So when I do, and where's the action here? It's okay. So then under this thing, I am going to make a series of a sequence of the dehydrated spec of that thing. In each one, I'm going to update. I'm going to dig into the transform local position fields, and there I'm going to call my my point pivot function, which is defined here. And this is a little sort of quasi-polymorphic thing that takes it gives out a vector 3, it takes two vector 3s, it takes something that could be either a vector 3 or a quaternion. If it's a vector 3, it assumes that it's Euler angles, Euler angles, and translates that into a quaternion. Then it does a little bit of math down here, which again, we're not going to go into now, but it's sort of straightforward. You translate to the point, then you rotate to one thing, then you rotate back, translate back, and you turn. So down here in pointer trans, I can zoom out a little. Okay, I'll evaluate that, and I get a ring of these pointers that are sort of turning around the central point, right? And I'm processing all these again as functional data structures in order to arrive at this non-functional data structure representation. Sort of riffing on that, I can do much the same thing again, but with slightly different parameters, and I get a lot more. And this is on the REPL, I don't need to reevaluate anything or stop the world. And you can do this in a running game, you can whatever you want. And then if I want to tweak some something here, let's see, I think spec scale, would this work? Okay, so 22, so let's make that 50. And make some larger. I can bring that down to 10. It makes a tight little sphere. And so you can keep tweaking things like that as much as you want. Let's make that 40. What does that do? Does that break? If they kill someone?
Well, you need three arguments.
Oh, you're right. And 3 arguments for that free. Many people do. Yeah. Okay. So oh, that's pretty cool. Yeah. So
That's pretty cool.
yeah. So I'm just gonna use that there. It's pretty cool. So okay, and then now as I'm evaluating things in the buffer, it just streams it directly to the Unity. This is running all the time. We're not using any REPL or anything. We wrote our own little REPL thing. It's a UDP socket, so it's running constantly. You never have to set it up or tear it down. There's some caveats with that, which I'm not going to go into now because the caveats. So
And REPL is being ported.
yeah, REPL is being ported right now by David Miller, so God among men, who was responsible for maintaining the Clojure CL log break. So we're waiting for that, and that'll be really cool and come with all kinds of other fun things that'll make integration easier. In the meantime, I'm using inferior list in Emacs. Anyway, so the process of sending things over the wire is pretty fast. So you can just lean on in Emacs on like the form you want to evaluate as a general animation. So in here, I'm just pivoting this around some point, right? Okay, so I'll show you guys one more thing. First, I'm going to tear down this scene, which I don't have a cute little thing for right now, so I'm going to do it manually. And this is what I'm about to do is probably going to be far too small for me to actually see, but bear with me.
So it's just selecting the
just
objects and deleting them.
going into the Unity console and getting rid of some stuff. Now, I hope this works. I'm going to go into another namespace I have. Okay. Are we good? Okay. And let's see.
Try to print out a keyword is our sort of
No,
pulse,
yeah,
pulse
yeah.
check.
So, okay, so I've got some stuff. I'm gonna make this big. Got some stuff to find here. I just made some platforms and then a tilted platform using the same technique. You can see the maps I'm using here. Just Clojure data again. You don't have to worry about the types of the loops here. These all correspond to Unity types, but whatever. You can just represent them as vectors, so you don't have to think about that or import all of the heterogeneous little things that might be in your scene. And then after that, I think we're running now, so I can just make a grid of little cubes there. You can see there's drifting off a little here, maybe if you squint. That's because this is all live, this is all running. They have physics attached to them. And then to make it more exciting, I'm going to position the camera a bit. Down here, and then and you can see everybody disintegrating down there.
Building collapse.
Yeah, so and like now, so this is all stateful, right? Obviously, we're not doing any of this in Clojure. I don't know how to. It would probably be tricky. But to set up the scene, we did all that in Clojure, and we can go back here and reevaluate collaborators, and they're back. So it swept up all of the existing game objects that I defined before and reinstantiated new ones up there. More elaborate versions of that macro might just keep them around, which would be more performant, and just change their fields such that they're back where they started. And this is a pattern in game development in general where you maintain an object pool and sort of enable or disable them. It means that you don't have to pay for allocation, which is by far the most expensive part of any of this stuff. You can do that to everybody. So those guys are back. Clobbers are back. can just keep going. You can make these guys get more of them. So now there's 20. It's 20 wide rather than 10 wide. You can change the make them use gravity themselves. So now it's a little bit slow because it just instantiated a bunch of things. So now those guys are also using gravity. Set that back to false. Increase their mass. So let's make their mass 100. Now that's going to mean when we, and then let's make the mass of the clobberers 1. And then when we drop the clobberers on them, they just sort of roll off because of the differences in their mass. Yeah, so that's, and this is an extensible system. You can extend it to types that you've had yourself. It's all macro. There's a macro that generates it. Well, I can go into details of it later, but point is all this AOTs. So all this is being constantly AOT'd onto some canonical representation, well, the DLL. And that means that for Hydrate to work out how to do all of this like type-specific stuff, I don't know, the interface into it is macros. It doesn't really matter right now. Anyway, so that's the that's Hydrate. This is sort of hints, hopefully, at some ways to integrate persistent objects with the imperative scene graph. And yeah, I think that's about it.
I have a question. I've used Android on Clojure on Android, and the load time is very slow. Initially, when the how do you have the same problem?
So we haven't even gotten there. Like we've been working on this increasingly sort of full time for 6 months, and now it's kind of working. But we haven't even tried exporting it to mobile yet. For one thing, we expect that the so you can't do reflective code emission in iOS, for example, and that means you can't use eval. So we have to figure out some way to, which we will, because we're going to have iOS export, but we need to figure out how to disable eval, for example. And under that umbrella, we haven't even tried it on Android.
But yeah, as a Unity dev, I have no reason to suspect the load time to be any different from had you written your thing in C#. The bytecode for many cases is indistinguishable from what C# generates, so it should behave.
Well, the problem is the loading the Clojure libraries in runtime. It takes 10 seconds just to start up.
Oh wow!
And on a mobile, it's just unusable.
AOT Clojure libraries?
Yeah.
Oh wow!
Yeah.
So I mean, Unity does. So yeah, this is the kind of place. I mean, people ask us why we didn't just write our own game engine, right? And just right in a weekend. So Unity, yeah, they've been building this thing for over a decade, and that's the kind of stuff that they take very, very seriously. So I'm sure they do bytecode level optimizations for mobile targets. So I would expect it to be better. Again, we haven't seen it, but I have faith that that class of problem will be better in Arcadia.
We also this is our branch of the Clojure CLR compiler, and when we encounter things like in Clojure or in the compiler that are showstoppers for us, we change them. So if there's something, if we can see some path to making it easier for a platform to do this, then we're not afraid to switch stuff up.
Right. Yeah. Because it's understood that you're running Arcadia code is running inside of Unity, and that's an assumption that we're comfortable to make. So we're not cowboy about it. We try and maintain parity as much as, or just stick to what Clojure CLR is doing as much as possible. But there are situations where, we already have def component. Inside of that is something called def class, which is a semantic deviation from Clojure. So basically whatever needs to happen to make this thing perform and work well, we're sort of willing to do. Because we have our own compiler. So.
I have a question. Where is Clojure CLR in relation to JVMC?
It's right up to date. So it's at 1.7. It's got transducers. It does not yet have a core because it's more, for all intents and purposes, it's one guy doing most of this stuff. So it's not an REPL. It does not have core async. Oh no, it does have core async, but we can't use core async because it uses a later version of of Mono. And that was actually one of the motivations, maybe Ramsey mentioned this, for our fork, was that Unity uses several versions ago version of Mono. But
several major versions.
yeah, several major versions. So
decade old.
decade old. So but we're in communication with David Miller, and we want to get core async in here as soon as we can. We might be able to make the canonical implementation of core async compatible with this version of Mono. That's the goal. But it's pretty much completely up to date.
Yeah, I just don't know much about Clojure CLR.
But yeah.
So, I think the strange talk you mentioned that the mono was going to actually be bumped up in Unity.
Yes. Yeah.
When does that happen?
Unity is, of course, opaque about that. Part of it may land in Unity 5, which is what they're sort of working on right now. No dates have been announced. Is the short answer, but soon.
It's not going to bump it up all the way, right?
It's going to bump it up to 3, not 4.5, which is what the rest of the civilized world is at. But it's a little better.
So what are the main differences between your version of Clojure and the one David Miller maintained?
The main visible one is what we're trying to do. We keep hitting these little bugs and little things, and our general policy is to patch them and then push them upstream into the main Clojure CLR. The last thing we want to do is to fork the Clojure CLR community or anything insane like that. The one thing we allowed ourselves to do, again, is introduce this new sort of dirty special form, def class, which enables you to use inheritance in type definitions. But then we papered under a bunch of macros and stuff, such that the only thing that really faces the user is without digging, is to generate a class that that extends mono behavior. So that's the main difference. Yeah.
And so we've already had a couple of our optimizations have been folded into the main line right now. So I think the big thing we did was we optimized type lookup by orders of magnitude in some cases, because again the performance pressures that we're under are sort of categorically different from anything else. So yeah, our policy is as much as possible patch and push upstream.
By the way, when you're updating these objects, like asset long and stuff like that, I guess it's the deep merge move thing.
Yeah.
How do you maintain identity for the objects?
Identity?
Because you're updating an individual object that's been created for it.
Oh yeah. So this is a def form. So the actual object in Unity is bound to that variable. So this says def scn, def scene clobberers. So this binds the variable clobberers, the var clobberers, to the result of this hydration. In other words, this is tied to this thing here. So then what happens when I redefine it is I delete that thing. It's a managed runtime, so there's no destructors or anything, but it nulls the object, and then it redefines clobberers as a result of doing this again. The other thing gets garbage collected, and you start over. So.
I have a question. Is the reason why they're having trouble updating to release because they heavily modified Mono?
Their modifications, as I understand them, weren't heavy. They are there. They have their own fork. My understanding is that it's a licensing issue with Xamarin and the Mono team.
It's a what?
A licensing issue.
Okay.
Which is really frustrating, actually. That it's not like a technical showstopper. But yeah, that's my understanding. It also works well enough for them, I guess. Part of the process of Unity supporting a new platform is them porting Mono to that platform. So I think updating Mono would mean they'd have to redo their ports across all their platforms. And Unity supports a lot more than what's listed in the window. You could make games for Roku, technically, if you really wanted to. I didn't find if that's a thing. But so a big part of their effort is just massively porting Mono. So yeah, I think it's mostly licensing and some technical constraints.
Yeah.
Well, why are you guys doing this? Is it for fun or do you have a?
Why are we doing it?
Because I like games. I was doing creative coding stuff for a while, and then I kind of Clojure. There weren't really any industrial strength creative coding tools in non-imperative frameworks. I mean, I'm sure there's comments to that, but for all intents and purposes,
Yeah,
like,
yeah, yeah.
I mean, you can wrap processing in like Clojure, but that's not going to do this. So yeah, so we just wanted to be making games and doing other game-like things like visualizations, installations, anything using Clojure rather than an imperative language.
Yeah, and I mean, I've been writing games for 5 years, in C# mostly, and it's just, I mean, C# is good. Like, could have been a lot worse, right? But the imperative stuff, it's just taxing after a while. And I've hit enough. I knew in theory, this stuff is hard to reason about and all that, but I've just personally hit enough, like, anecdotal, real life. I have no idea how you arrived at this state, and I have no way of knowing how you arrived at that state, and the client is coming in 6 hours, right? So like I've just been there so many times that I'm excited to try something new, right? So and this everything that I've seen in Clojure, like again, I'm very new to the language. Everything that I've seen has been so good, so consistent, and well reasoned. It's just a joy to write in. So that's why I'm doing it.